We're just going to multiply some more radical expressions, but this time we get to do some fun things like distributive property and multiplying binomials. I mean, it just gets too cool, doesn't it? So let's just refresh our memory. What do we want to do today? Odds or evens? It honestly doesn't matter. Let's do evens today. We're going to do evens together. You'll do odds, obviously, or maybe the whole rest of the worksheet. We'll see. So I'm going to take square root 5 times square root 10. This is hopefully a refresher. We know that we're just going to multiply and get square root 50. Then we're going to break that down into perfect square and non-perfect square. What's a perfect square in 50? Yep, 25. So this gives us 5 square root 2. Yes? Nothing difficult there. Okay? Let's go further down. That one's not difficult. Oh no, that was kind of cool. Here we go. Negative 4 times 5 times 20 is 100. Is that right? Yes, it is. Oh, that one's too easy. Negative 4. Oops, I took the square root of that and I shouldn't have. It's not under a radical. So that 4 just comes down. Square root of 100 is 10. So that just gives us negative 40. Nothing too exciting there. Okay, let's jump down to 8. Because I want to spend more time on what's coming up later. On number 8, we're going to multiply like we did before. The 4 stays on the outside because that's 4 times 1. We're going to multiply what's underneath. So 18 times 3 is going to be 54. A to the second times a to the second. When I multiply like bases, I add my exponents. Okay, so the 4 hangs out. Now I want a perfect square in 54. Okay, perfect square in 54, that's divisible by 9. 9 and 6. Yep. A to the 4th is a perfect. So I get 4. Square root of 9 is 3. Square root of a to the 4th is a squared, and I have square root 6. So my final answer is 12 a squared square root 6. Okay? Same thing's going to happen here. Negative 4 times nothing, so that's going to be negative 4. 28 times 7 equals 196. Pause for a second. Think, why does 196 look familiar? Yep, that's a perfect square. Okay, so x to the first times x to the third is x to the fourth. So this gives me negative 4. Square root of 196 is 14. Square root of x to the fourth is x squared. 14 times 4 is negative 56x squared. And once we've taken the square root, we don't put a radical back on it. It's like it's freedom. Woo, I'm out of the radical. Okay, we're going to do that same thing now, but now we're just going to distribute. So it just looks more fun, doesn't it? So I'm going to take 2 square root 5 times square root 6. That's going to give me 2 square root 30. Yes? Plus 2. Now 2 times 2 is 4. Wow, forgot my basics, didn't I? Times the square root of 5. Yes? Now, are those like terms? Can I add them just as they are? No. Let's see if we can break down 30. 30. What goes into 30? 5. Not a perfect square. 6. Not a perfect square. 10. 3. Oh, wait, we're done. That's all we can do. These are not like radicals. They just stop right there. Done. Okay, number 14. Let's multiply that. Negative 5 hangs out. 3 times 10 is 30. Hey, don't trick us. We've seen this before. Can't reduce that one. Square root 3. So I'm going to draw my arcs this way. Times square root 6 is a square root 18. 30 doesn't break down, but 18 does. And you're going, so what? Well, you have to have it in simplest form. So 18 breaks into 9 and 2. So I have negative 5 square root 30. Square root of 9 is 3 square root 2. Not like radicals. Can't combine them. That's your final answer. Let's go to the next page. Okay, so now we're going to distribute again. I'm going to draw it up top so I have more room. I'm going to distribute this to this. So 5 times 4 is 20. Square root 42x. Okay? And we'll go back in just a bit and see if we can simplify that. Now we're going to take 5 times 4. 5 times 4 is 20. Square root of 42 times 7. 42 times 7. It's going to give us 294 x squared. Okay? Now, I want you to pick up on something here. See how we had a 7 there? And we're multiplying times 42. What goes into 42? 6 and 7, right? So use that to your advantage. Oh, wait, I took a 7 times something that had a 7 in it. I'm going to try a 49 on that one and see if that can be reduced by 49. So I'm going to take, I know I'm starting in the second one, but 294 divided by 49. Yep, there it is. It's 6. So that one breaks into 20 square root 49 x squared, and then we have a leftover 6. So kind of watch for that. If you're going, hey, those both have a 7, pay attention. Okay, oops, that should be a plus sign right there. Now we have a 20. 42, what does it break into? 42 is divisible by 3. 42 is divisible by 6. Yep, nothing. We got nothing there. So this gives me 20. That one stays. This one I can multiply. So 20 square root 42x, that just hangs out. 20 times square root of 49, oops, can't see that, is 7. Square root of x squared is x times the square root of 6. So that gives me, I'm cramming it in here, 20 square root 42x plus 20 times 7 is 140 x square root 6. That's your answer. I know, you're going to go, I'm not going to go out in the everyday world and do anything with that. You're right. But you will see later on, and there's a reason they're having us practice them in Algebra 1, because you're going to see stuff in geometry and Algebra 2, so you need to be prepared. Can we skip one of these, because we're just running out of space. Let's do one more, number 20. And I would really encourage you to turn yours off and see what you do on this one. Yep. Oh, no, let's do 18 too. I'm not skipping them. Okay, so here we go. 7n cubed, because there's nothing underneath a radical there. It's only the square root 6n. But you put the number in front. You don't put the radical in front and then stick a number behind it, because it's too confusing. It could be, is it under the radical or not? So you always put the number out in front. Now I'm going to multiply 6 times 12. That's going to give me the square root of 6 times 12, 72n. Oh, hey, did you pick up on that? We have a 6 here. We're multiplying times something that has a 6. So I might want to keep that in mind when I go to reduce this. So I have 7n cubed. Square root is 6n. And some of you might remember when we've simplified 72 before. Perfect square of that is 36. Now, 36 times 2. Man, they are not wanting us to combine like terms. So I get 7n cubed times the square root of 6n plus 6 square root 2n. Are these like radicals? Nope, we're done. That's all we can do with that one. That's our answer. Okay? 21 does about the same thing. Let's jump down to 22. On number 22, we're going to distribute, okay? So, or FOIL, or distribute twice, whatever you want to do it. So I'm going to take 6 times 2, sorry, that's a 5. 5 times negative 2, that gives me negative 10. And then 5 times square root 5 is a square root. Okay? Plus, because I'm taking a negative times a negative, 4 times 2 is 6 square root 5. Minus, because I have a negative times a positive, 4 square root 25. Because I'm taking 5 times 5. Now let's do that again. I took 5 times negative 2, got a 10. 5 times square root 5, I get a 5 square root 5. Negative 4 square root 5 times negative 2, I can multiply the 4 and the 2, and I get 8, not 6. That's the reason you're all looking at me funny. No, I'm not going crazy. I can't really see your looks. Square root 5. Then I'm going to take negative 4 times 1 gives me negative 4. Square root 5 times square root 5, I'm going to actually multiply those, and I'm going to get square root 25. Now we're going to go and take the square root of that in just a second. So I get negative 10. Ooh, yay, I have like terms. So I have 13 square root 5 minus 2 times, what's the square root? Oops, don't do that mistake. 4 is not under a radical. I can't take the square root of it. It's just 4. Then I can take the square root of 25, though, and get 5. So I have negative 10 plus 13 square root 5 minus 20. Now I have like terms again. So negative 20 and negative 10 is negative 30 plus 13 square root 5. That's my final answer. Isn't it fun? We thought we had like terms here, but then yay, we have more like terms. So it just gets more fun as we go. Okay, let's look at 24. I'm going to do the same thing. I'm going to take square root 5 times square root 5. Square root of 5 times square root of 5 is square root 25. I know that reduces. Just relax. We'll get to that. But just write it down, especially since it's new. Now I'm going to take square root 5 times square root 3. That gives me square root 15. Now, notice I just moved my finger over. Negative square root 3 times square root 5 is a negative square root 15. Minus square root 3 times square root 3 is square root 9. Woohoo! This is a fun one. So now we have 5 plus square root 15 and negative square root 15. Those drop out. So then I have a minus, because I already have the plus written down, minus square root of 9 is 3. So that gives us 2. Oh my, that brings back so many fun memories of Algebra 2. You're going to see this in rational expressions. Oh, wow. I'm so excited for you. It's going to be fun for you when you get there. Okay, here we go. On number 26, we're going to multiply again. So negative 3 square root 3k times square root 3k is negative 3 times the square root of 3 times 3, which is 9, k squared, plus, because I'm taking a negative 3 times a negative 5, 15, because they're both on the outside, square root 3k. Now, I'm going to take the 4 times everything, so I'm going to distribute again. So 4 square root 3k minus 4 times 5, which is 20. Okay, you with me? So we can simplify here. We have a negative 3. Square root of 9 is 3k to the first power. Because when I take the square root, I divide the exponent by 2. Plus, oh look, like terms. So I have 19 square root 3k. And notice what's under the radical does not change. They're just like radicals. They just keep hanging out. Minus 20. So now I get negative 9k plus 19 square root 3k minus 20. Okay, good. One more. So we're going to take and multiply here. We get 3 square root 2 times square root 2 is square root 4. Minus 3 times 3, which is 9. Square root 2 times square root 5r is 10r. Okay, so I've multiplied that by both. Now I'm going to multiply this. Plus square root 10 minus 3 has nothing to multiply by, but I can multiply the stuff underneath. 5 times 5 is 25r. Okay, and don't get too hung up about, oh my gosh, no, just relax and do the steps. Okay, so now I'm going to get 3 times square root of 4 is 2. These look like they're like terms, but are they? Nope, because this one has an r and this one doesn't. So you can't do anything with that right now. So that's minus 9 square root 10r plus square root 10. Minus 3, I can take the square root of 25 and get a 5, and I have an r left underneath. So I have 6 minus 9 square root 10r plus square root 10 minus 15 square root r. Wow, they are trying to get us to combine things that we can't. Because look, they give us 10s, but this doesn't have an r, so can't combine that. Here we have an r in the radical, but we don't have that. And they're also trying to make you think that 10 can be simplified, but it's not a perfect square. People, that is your answer. That's all you're going to do with that one. Okay, good. So check with your teacher as your exact assignment what you're going to be doing. But that is it for notes on day 2 of multiplying radicals. Thank you very much. If you have any questions, you know where to find us.